What is optical mineralogy? Optical mineralogy is a branch of mineralogy that studies the interaction of light with minerals. It involves the use of polarized light microscopes and other optical instruments to study the physical and optical properties of minerals, such as their crystal structure, color, birefringence, and pleochroism. The study of optical mineralogy can provide valuable information about the chemical composition and geological origin of minerals. By observing how a mineral interacts with light, mineralogists can identify the mineral and determine its properties, such as its hardness, cleavage, and refractive index. They can also use this information to classify minerals into groups based on their physical and optical properties, which can provide insights into their geological history and formation. One of the key tools used in optical mineralogy is the polarized light microscope, which uses a polarizing filter to polarize light and a second filter to analyze how the light interacts with the mineral sample. By rotating the sample and the filters, mineralogists can observe how the mineral changes in appearance and color as the light passes through it. This can reveal information about the mineral's crystal structure, such as the orientation of its cleavage planes and the presence of twinning or other defects. Another important technique used in optical mineralogy is thin section analysis. Thin sections are slices of rock or mineral samples that are less than 30 microns thick, which are prepared by grinding and polishing the sample until it is transparent. By examining thin sections under a polarized light microscope, mineralogists can observe the mineral grains and their interactions with each other and the surrounding rock. This can provide insights into the geological history and processes that form the rock, such as the presence of mineral veins, the deformation of the rock, and the conditions under which it was formed. Optical mineralogy has many practical applications in fields such as geology, mining, and materials science. For example, mineralogists can use optical mineralogy to identify minerals in or deposits and to determine the most efficient methods for extracting the minerals. They can also use it to study the properties of minerals in industrial materials, such as ceramics and metals, and to develop new materials with specific optical properties. Overall, optical mineralogy plays a vital role in the study of minerals and their properties. By using light to probe the inner workings of minerals, mineralogists can uncover valuable information about the geological history and composition of our planet, as well as develop new materials and technologies. What does optical mineralogy deal with? Optical mineralogy is a branch of mineralogy that focuses on the study of the interaction of light with minerals. It deals with the physical and optical properties of minerals, including their crystal structure, color, birefringence, and pleochroism. One of the main goals of optical mineralogy is to identify and classify minerals based on their optical and physical properties. This is important for a variety of reasons, such as understanding the geological history and formation of minerals, as well as identifying minerals in industrial applications and/or deposits. To achieve these goals, mineralogists use a variety of tools and techniques, including polarized light microscopy, thin section analysis, and X-ray diffraction. Polarized light microscopy involves using a polarizing filter to polarize light and a second filter to analyze how the light interacts with the mineral sample. By rotating the sample and the filters, mineralogists can observe how the mineral changes in appearance and color as the light passes through it, which can reveal important information about the mineral's crystal structure and other physical properties. Thin section analysis involves preparing thin slices of rock or mineral samples that are less than 30 microns thick. These thin sections are examined under a polarized light microscope, allowing mineralogists to observe the mineral grains and their interactions with each other and the surrounding rock. This can provide insights into the geological history and processes that form the rock, such as the presence of mineral veins, the deformation of the rock, and the conditions under which it was formed. X-ray diffraction is another important technique used in optical mineralogy. This technique involves shining X-rays onto a mineral sample and analyzing how the X-rays are diffracted by the crystal structure of the mineral. By analyzing the diffraction pattern, mineralogists can determine the crystal structure and chemical composition of the mineral. Overall, optical mineralogy deals with a wide range of topics related to the physical and optical properties of minerals. It plays an important role in identifying and classifying minerals, understanding their geological history and formation, and developing new materials and technologies. Optical mineralogy has many practical applications in fields such as geology, mining, and materials science, and continues to be an important area of research and study for mineralogists and other scientists. Please don't forget to subscribe to my channel and turn on notifications.